Hi, this is Dr. Syed from India. Today I am going to teach you about NEBOSH International General Certificate, element number 10, part 2, electrical hazards and control. Now we will discuss about the current shock effects on the body. An electric shock can result in a convulsive response of the nervous system, where the passage of electricity through that particular part of the body. So, we are seeing here a diagram. In this diagram, you are seeing the electricity milliamperes starting from 1 milli to 1000 milliamperes. That is, when the current passes and the amount of current induced in your body, what happens? We can see at the right side. If the current passes at a milliampere of 1, there will be threshold of sensation. When it goes up to 2, there will be mild shock. Again, when it goes up to 5, the GFCI will trip off and you will be saved. And it rises to 10 milliamperes, but you can't go out from the shock. When it rises to 20 amperes, you will get muscle contraction. When it rises to 30 milliamperes, you will get suffocation. Like this, when it rises up to 100 milliamperes, your heart will get stops. Your heart will stop the beatings. Like this. If it goes to 300, your breathings will be stopped. It goes to 900, you will have severe burnings. The 1000, it will light up to 100-watt bulbs. So these are the severity of the current shocks on your body. Current shocks can cause the muscles to get contract. If you grasp a live wire in the palm of your hand, the shock will cause the hand to close around the wire and it will grip it more firmly and can't be released. The muscular contractions caused by electric shock can have different severe effects. The current shock effects are as follows. If a serious shock which passes through the heart may cause fibrillation, the interference of the timing of the beats of the heart can cause cardiac arrest. And the interference with the muscles control is serious. The breathing may also be serious and it may cause respiratory failure. Both of these situations may be considered as fatal ones. Even though the current doesn't pass through the major organs of the body, the shock effects can have serious consequences. The muscular reaction caused may result in arms, legs, torso, or neck convulsing. This can be sufficient to knock the victim out of balance and can cause a fall at any position. The fall may result with a serious injuries than the shock itself if the fall is from over heights. The falling force can cause fracture of bones. The passage of electricity can also cause burns on the body. We can't consider that any voltage at 240 is always safe. But the low voltage may reduce the risk. We should always consider that the 240 volts is potentially fatal. The electrical resistance of the body can vary as per the skin conditions like dry or moist. And it would also the path traveled to the body between the entry and exit points. We know that the skin resistance is quite high, although it may vary from less than 1000 ohms to above 5 lakh ohms for dry and wet skins. Due to the fear, the moisture may increase on the skin, and further the resistance is lower where there is a continuous contact with an electrical source. Most of the shocks are of a very short in duration, and the person remaining in contact with the live source for less than a second. But it depends on the current voltage received by the person for a long time, which can have a fatal shock. We can calculate the amount of current received from a shock by applying the following equation. As per the Ohm's law, I is equal to V by R. Consider an example, that is, assume that the voltage of 240 volts from the electricity supply, which passes through a human body, the body resistance is 1500 ohms. Then the current received may be as follows. Apply the Ohm's law. I is equal to V by R, that is 240 divided by 1500. It comes to 0.16 amps, that is milliamps. The current is measured in milliamps, that is 1000 of an ampere. 0.16 amps can be written as 160 mA. The effects of current at various levels can have different levels of harm on the body. If the current is between 2 to 10 milliamps, the body will suffer with a painful sensation. If the current is between 10 to 25 milliamps, the body will lose the ability of moving. If the current between 25 to 80 milliamps, the person have breathing difficulties, danger of asphyxiation, loss of consciousness, and finally respiratory failure. If the current is between 100 to 200 milliamperes, the person have a fatal injury that's called a ventricular fibrillation. If the current is above 200 milliamps, the muscular contractions become so severe that the heart is forcibly clamped during the shock. This clamping protects the heart from going into ventricular fibrillation, and if the victim is provided with CPR, that is cardiopulmonary resuscitation, he can be survived. Severe burns may occur over the current of 200 milliamps. When the person gets shocks from the source, the entry and exit points of the body to be taken into consideration, or the body contact with the ground or another conductor. Generally, hands, arms and feet are the points through which the current takes a path into the body. This path that the current takes place can have least resistance. If the path is through the heart or respiratory organs, then it may be more dangerous. However, the severity of the shock depends on the following conditions of the victim. That is, healthy body. The person may have strong body, unhealthy body. The person may have weak body. A person may have weak heart or a healthy heart. Now we will discuss about how to protect the electric shock victim. Electric shock victims should get quick medical treatment. Always there should be a standby of quick medical treatment. However, it's important not to touch a person who remains in contact with an electrical source, as you may also receive a shock. So don't touch the victim. The first action to be taken is to break any continuing contacts between the victim and the current. In some situations where there is a high risk of electric shock accidents, you need a qualified first aid personnel and a trained CPR person who should be ready, available for the treatment. What you should do? Immediately switch off the power supply or disconnect the equipment. If this is not possible or you get delayed to do this, the victim should be separated from the current using a non-conductive material like wooden stick, broom, or a piece of long wood, or take a dry cloth and drag the victim from the source. Then immediately start artificial respiration and continue until the victim get recovered. In some situations where there is a high risk of electric shock accidents, a qualified first aid person and a trained CPR person should be readily available. And when there is a risk of internal injury which may not be visible, there should be always an emergency medical attention to attend the situation. Electrical shocks can create burns on your body. We should know how to treat the burns due to the electrical shocks. Electric shock burns are divided into two groups. The burns from the direct contact with a live conductor, that is one, and the burns which arise directly from situations where there is no contact with a live conductor. For an example, you are struck by a lightning. Now we will discuss about electric shock direct burns. When the current passes along any conductor, it is accompanied with the release of heat. When the current passes through the body, it is likely to cause burns. The heat created by a current is directly related to the amount of the current and the resistance encountered. When the current is higher, there will be more heat generation and the severity of the burns will be very much. This is one of the examples of electric shock direct burns. Similarly, if the resistance is high, the greater the heat generation and more severe burns will result on your skin. Because the skin consists of highest resistance in the body, the surface of the skin which is in contact with a live conductor will have more severe burns. Just see the diagram here. This is another example of electric shock direct burns. We are seeing a diagram here where there is a wound on the palm which has been created by the electric shock. This happens due to the high current which can create internal bonds along the path of the current traveled through the body. These may cause damage to red blood cells and muscle tissues. These wounds are deep-seated and very slow healing wounds. Now we will discuss electric shock indirect burns. Arcing is one of the examples of indirect burns. Arcing is another type of burn when a person touches a live wire conductor. The possibility of arcing may occur due to a conductor with a very high potential which is brought into close contact with another earthed conductor. The voltage may be large enough for the natural insulation of the air between the two conductors just to break down, and spark may jump in the gap. This will happen, the indirect burns, that is arcing. You are seeing a diagram here. In this diagram you can see the different circuits has been connected in different ways. You can see how the arc has been created here. We already discussed about the arcing. The arcing may occur due to a conductor with a very high potential which is brought into close contact with another earthed conductor. This is the reason for arcing. Due to the large voltage, the natural insulation of the air between the two conductors, which is not enough to break down, but when a spark may jump in the gap of two conductors, this causes to ionize the air and lower its resistance, which in turn allows the current to increase, by which an electric arc is set up between the conductors. It's possible that very large currents can flow through the arc in a very short time, possibly even less than 1 second. Just it is like lightning. The another reason of arcing is due to the live conductor which is uninsulated, or when the insulation is insufficient to prevent the force generated by the high voltage, or when a fault will develop exposing the live conductor and the other earthed conductors, which may be a metal object on the ground or a person. This is one reason. There is another reason for arcing, that is when a person gets too close to a overhead high voltage power line, he may be subject to a flame burn from the arc. There is another type of hazards due to the arcing. Arcing generates ultraviolet radiations which can burn the skin and the retina of the eye, which causes arc eye or eye flash. Burns may result from radiated heat, where the body absorbs the heat energy at a distance, which results in burns in the body. Now we will discuss about the different causes of electrical fires. The creation of fire, which requires three important elements as follows. You want to create a fire, you need three things, that is a source of heat, then you need combustible materials such as fuel or some other thing, and the another one is you need oxygen. So you need all these three elements. Electricity may provide the source of heat in two different ways as follows. Arcing is the main reason for the creation of fire in the electric circuits. This is the generation of electrical sparks or arcs between an uninsulated or poorly insulated conductor and another earthed conductors. A plug can create a fire, but it needs some combustible material to burn. Then damage of insulated wire can create fire, or that is arc, or broken parts or incorrect wiring of a connection may be the other causes of fire. The another reason of fire, it is when the conductor gets overheated due to poor or inadequate insulation, which allows the natural heat created by the flow of electricity to escape. The another reason is due to the overloading of the conductor with more high current above the capacity of the wire. And the another reason is due to the excessive resistance with the conductor and due to a lot of bends and rounds over the drum. In either of these above cases, there is a possibility of temperature generation, and it's sufficient to ignite any combustible material either in contact with source of the heat by which fire may be started. In some circumstances, there will be flammable vapors which may be present in the atmosphere and can catch fire. One of these examples is a painting spray booth. Electrical fires may be most dangerous as we can't extinguish with water, as water is a good conductor of electricity and it's a live hazard. So do not extinguish the fire, electrical fire, with water. Now we are going to discuss about the hazards of portable electrical equipment. A lot of hazards are there in the workplace due to the usage of portable electrical equipment. A lot of electrical accidents occur with portable electrical equipments in the workplace. The common accident results in electric shocks and fire accidents. These are the common ones. Most of these accidents are caused due to the faulty leads connected to appliances and faulty equipment which you are using in the workplace without any inspections. Now we will see how to prevent the electrical accidents. The use of the electrical equipment in an appropriate conditions. So you should take care that you should use the electrical equipment in an appropriate conditions only. Do not lay down the cables in the presence of water. Take care. Do not lay down the cables in the water, as damaged cables can create electrical shocks and accidents. See, these cables may have some damages by which you will get electrical shocks if you put them in the presence of water. Take care of the trailing cables which may create shock hazards due to the cable damages by the vehicle moving over them. You should take care that cables should not be laid down and the vehicle should not pass over them. Remove or insulate well damaged cables before use. Before using the cable, check up the cable thoroughly and check up for damages. If there are some damages, they remove those cables and use the good cables. The another thing is, don't use damaged equipment. Check up the equipment, that the equipment is in condition or not. If there is some damages or any errors with the equipment, do not use it. Send it for repairs. So you should have a program that a routine repair and maintenance to be carried out for all the electrical equipment, and you should maintain a log for that. The another thing is, damage or missing insulation or insulation failure can easily expose people to the risk of electric shocks. So if any damages on the insulation can give a shock to a person who is carrying it. Equipment to be repaired and serviced only after disconnecting the power supply. See, when somebody reports to you that this equipment is showing some error, when you want to repair that equipment should be disconnected from the power supply. Then only you should carry out the repairs. The electrical hazards consist of not only the shocks but personal injuries, burns and fire from shocks. You should take a note that any failure in the electrical circuit will have an impact on all machines and other systems on that circuit. So you should take care of the circuit properly. The interruption in the power supply. This is the biggest disadvantage to the company, to the industry, which may cause inadvertent mechanical movement of plant or machinery, which may cause a risk. So try to see that there should not be any interruption in the power supply. It's also possible that there will be the risk of failure of electrical protection devices such as fire alarms and smoke detectors or machine guards. Now we will see how to control the electric hazards. Ensure that the equipment has been disconnected. First you will have to see that all the equipment should be disconnected from the power supply and ensure that it can't be reconnected in any circumstances. Then handle the equipment very safely. You should select the suitable equipment as per the requirement of the job and weather conditions. You will have to see two things. One is what type of job that you are doing. For that, what type of equipment you need it. And another thing is, because it's electricity, you should consider the weather conditions, whether the weather is a wet weather or hot weather or it's a raining. You will have to consider all these things. Then use appropriate protective devices. So there are many types of protective devices. You will have to choose a suitable protective device. Then effective inspection and maintenance routine undertaken by a competent person. A competent person should always be with you. My dear students, this is the end of part 2 of electrical hazards and controls. Work safely, live safely.